What's up, calculus students? Mr. Messner coming at you with the first lesson of the very important Unit 7, where we realize that position, velocity, acceleration are just a original function, its derivative, and its second derivative. You can think of position as an f. You think of position's derivative as an f prime, which is like a v. And you can think of position's second derivative, or the rate of change of the first derivative, how velocity is changing is acceleration. Okay, so the key to this unit is understanding that we've really done all this stuff before. With one exception, is we are going to look at some position values and figure out how much did our position change. So we have this, but let's say I have a start and an end. We know that my function is increasing or decreasing. Well, we're going to just be like a position's derivative tells me how my position is increasing or decreasing. We're going to find out how much we increase. How much do we decrease? We find that by finding actual positions and just finding the change or the displacement of the position. Okay. So every single time, we're going to pretty much do what we did in Unit 3, which is a full first and second derivative analysis. We are talking about something moving on the x-axis. So we have a position on the x-axis, x of t. Most students don't like this x of t, which means I can just change it to p of t, where you don't get confused. And we will look at p prime. Now, this is the change in position, which would be in meters per second. This is just the velocity. P prime is 3t squared minus 6t minus 9. I will factor out 3. I'm looking at things from 0 until 4. This is important. Talk about that in a second. Going to factor, set equal to 0. I'll get t equals -1 and 3. Now, typically, we will put both -1 and 3 down, but this is going to be important in our Unit 7. We're not going to look at everywhere. We're going to look at a specific part. So we'll have, for most of the questions, a start and an end, which means I only care about 3. Cool. We'll do a sign analysis. Now we know that the next 0 is at -1. So I actually know that I could plug in 0 if I wanted to. Here, we know that this is the last 0. So that means I could plug in 4 or 5 or 6 or 7 because I don't have any other zeros to the right of 3. So just like keep that in mind that even plugging in 4 is a good test point, even though it's at the end. If I plug in 4, I can see I got 3 times a positive times positive, so positive. And if I plugged in 0, I'd get 3 times a negative times positive, so it's negative. And this is telling me that my position is decreasing and increasing. Now, position decreasing means I'm moving left. Or when my velocity is negative, my position is decreasing. I'm moving left. This is right. And the extra bit of analysis I'm going to do is I'm going to find positions at these important times, at 0, at 3, and at 4. And I get the position at 0 is 0. Cool. I get the position at 3 is 27 minus 27 minus 27. That's funny. And I get the position at 4 is 64 minus 48 minus 36. So 64 minus 48 is 16. Minus 36 is negative 20. I could just double check that. Okay, good. 36, 20. Okay, cool. So this is new. It's like finding the function values, f values. We haven't really looked at f values before. We just said, oh, f is decreasing then increasing. Now we're going to say, since my position goes from 0 to negative 27, my position decreases 27. This is how much my position goes down. Then it increases 7. I go from negative 27 to 20, so that means it increases 7. That means if I looked at the position changing from 0 to 4, I could see I decreased 27, I increased 7, my position changed by 20. I ended up 20 to the left of where I started. Cool. We also need a second derivative analysis, p double prime, which is equal to velocity's derivative, which is equal to acceleration. And we have done this before. And we have done second derivative analyses. But what we have to understand is that the second derivative will tell us about the first derivative. Well, the first derivative is the velocity. Second derivative tells us about the first derivative increasing or decreasing. Plug in something like 3, I get positives. Plug in something like 0, I get negatives. I realize my velocity is decreasing then increasing. Cool. The particle is at rest at time equals -1 and time equals 3. We're only going to worry about time equals 3 because we're talking about t from 0 to 4. So that's why I'm going to say that. And boom, we're good. This is all we have to do is the analysis, and then all the questions we should be able to answer as long as we can interpret things. What is the position, velocity, and acceleration of the particle at time 2? Is the particle going toward or away from the origin at this time? Okay, well, so we need to figure out the position from the position function. This is the position on the x-axis, so that means we're left and right. So t cubed minus 3t squared minus 9t. And my position at time 2 is 8 minus 12 minus 18. So my position should be a negative position because I'm between 0 and negative 27. I can see we decrease a lot. So we get negative 4 minus 18 is negative 22. All right, cool. My velocity is how my position's changing. My velocity at time 2 is 12 minus 12 minus 9. It's negative 9. Now, what does that mean? My position is decreasing by 9 meters per second. Y's per x, meters per x. My position is decreasing. That means I'm moving left. I'm to the left, moving left. I'm have a position that starts at 0 and goes to negative 27. So I'm to the left of the origin and I'm moving left. This is one thing that's kind of confusing to students is the whole, this is actually from P's original graph. P double prime at 2 is 6. So that means my velocity is increasing 6 meters per second, or 6 meters per second squared. Now, this is important. At 2, my velocity is negative, but my acceleration is positive. My velocity is negative, but my velocity values are going up. If you have negative values going up, you have a situation where your values are getting closer to zero. At 2, my speed is decreasing. Because my velocity and acceleration have opposite signs. My velocity values are getting closer to zero. My velocity values are negative and increasing. It's not a question. I'm just throwing it in there. Say V and A have opposite signs. Particles moving to the left when its position on the x-axis is decreasing. When the velocity or the first derivative is negative, that's going to be from 0 to 3. How far does it move to the left? We've already done this. So the position changes by negative 27 meters, units, which means it moves 27 to the left. So my position decreases by 27. I move left 27. Velocity increases when the first derivative increases. That's when the second derivative is positive. My velocity is increasing from 1 to 4. That's when my second derivative is positive. So like you see, all these questions are easy to answer. Okay. Speed is increasing. We got to talk more about speed. Okay. Speed is increasing when your velocity values get further away from zero. So here, if I start with a velocity of 0 and I have a positive acceleration, which means my velocity is increasing 1 meter per second. So watch. Here's my velocity of 0. Every second, my velocity is going to increase 1 meter per second. So here he goes. 1, 2 seconds, 3 seconds, 4 seconds. Cool. Well, what if I had a velocity that was negative 5? If a velocity is negative 5, that means my position is decreasing 5 meters per second at this time. But since I have acceleration, my velocity is increasing 1 meter per second per second. Negative 5 is going to go to 0. Notice my acceleration is positive, but my velocity is negative. For 5 seconds, I will be slowing down. There's 1 second, 2 seconds, it's going to go off. Oh, what happened? Clear. Let me just try to show you quickly, because this guy is like slowing down my computer. When your acceleration and velocity are going in the same direction, you will speed up. When your velocity is decreasing from positive values to 0, you're slowing down. When it's negative and getting bigger, you're speeding up. Here's positive going further away from 0, speeding up. Here's negative going away from 0. Here's positive velocity values going further away from 0, speeding up. Here is, boom, a negative velocity, which means my position is decreasing, but my velocity is decreasing. Negatives getting more negatives, speeding up. Okay? So what we like to say, I'm going to get rid of this guy, is speed increases when the velocity and acceleration are in the same direction or have the same sign. This is when your velocity gets further away from 0. Your velocity can be negative and decreasing. Your velocity can be positive and increasing. When your velocity is negative and your velocity is decreasing, your acceleration is also negative. When your velocity is positive, your acceleration has to be positive because that's when your velocity is increasing. And again, this is P prime and P prime, which has told us about P double prime. Hope we understand this. It's stuff that I do like saying your velocity values are getting further away from zero, which are when your velocities are negative and decreasing, and when your velocity is positive and increasing. This comes from looking at your first and your second derivative analysis. Remember, P prime positive negative tells me when P is increasing or decreasing. That's this part. P double prime positive negatives tells us about P prime increasing or decreasing. That becomes this part. We will look at the first derivative analysis and the second derivative analysis because this is V and this is V. So we are negative velocities that are getting more negative from 0 to 1. We are positive velocities getting more positive from 3 to 4. So it's like you put these on top of each other. 0 to 1, negative, negative, 1 to 3, negative, positive, 3 to 4, positive, positive. Okay, so 0 to 1 and 3 to 4. These are times. These are when velocity and acceleration have the same sign. This is when P prime and P double prime have the same sign. What is the displacement of the particle over the time interval? Well, my particle started at a position of 0. My particle ended at a position of negative 20. So over the entire time interval, we would say my particle, the position decreased 20, or we went overall, we ended left of where we started. 20 left of where we started. Cool. All right, great. So it's just F prime, F double prime. Oh, look, I'm giving you a velocity graph. This is how position is changing. When has a particle stopped? Particle stopped is when its position is neither increasing nor decreasing. When the position is flattened out, that's when the position's derivative is 0. Okay, I need to figure out when P prime is 0. V is P prime. I need to figure out when this is 0, 0, 3, 5. When is the particle moving left? Particle is moving left when its position is decreasing on the x-axis. Again, we're on the x-axis, so my position is decreasing on the x-axis if my position is decreasing on the x-axis. I'm moving to the left if this is 87654. Okay, cool. So that's when my derivative is negative. When is my derivative negative? It's not when my derivative is decreasing, it's when is my derivative negative. That's going to be from 3 to 5 times. This is when things get tough when I put out points. So I'm going to say when t equals 3 to t equals 5. Or I could say my time value is between 3 and 5. These are not points. Sometimes when we use that 3 to 5, we think of it as an x, y. So let's not do it. What is the acceleration of particle negative? Well, the acceleration's negative refers to the derivative of the derivative being negative, which refers to the first derivative, or the velocity, decreasing. These are all questions that you've seen before. When is my velocity decreasing? That's going down. Not really worrying about positive or negative. It's just when are we going down? When is my velocity going down? Is from 2 to 4. Or 2 to 4 here. Speed decreasing. Okay, let's think about this. Speed is decreasing when your velocity values are getting closer to zero. When you're getting closer to stopping, velocity values approaching zero is when your velocity values are positive but going down to zero, or your velocity values are negative but going up. So if your velocity is positive and decreasing, your velocity is positive and your acceleration is negative because that refers to that. That's when your first derivative is positive, but your second derivative is negative. If your velocity values are negative increasing, that's when your first derivative is negative, but your second derivative is positive. Okay, so what do we see? V and A have opposite signs. Or, look, my velocity values are getting further away from zero. My velocity values max out and then start getting closer to zero. Here's my velocity values that are positive and decreasing from 2 to 3. Then my velocity values hit zero, my derivative hits zero, my particle flattens out, stops, then starts going to the left because my velocity is negative, my position is decreasing, and it will speed up to the left until it hits a maximum negative velocity or minimum velocity, which means it's traveling to the left, but then my velocity starts getting closer to zero. My velocity is negative and increasing from 4 to 5. These are my velocity values from that are negative and increasing. These are velocity values that are positive and decreasing. Cool. All right, that's it. It's like stuff we've done before. Now notice, I did not ask you about any positions. We will be able to find some positions starting next class, given the graph of velocity. Show you. All right, velocity is the derivative of position. Particle is stopped when the derivative is zero. When the position is neither increasing nor decreasing. The derivative, p prime, v, velocity is zero at 1 and 3. When is the particle moving left? When its position is decreasing on the x-axis, that means the derivative is negative. When the derivative is negative, this is the derivative. The derivative is negative between 1 and 3. Not going to put points anymore. When is the acceleration positive? The acceleration will be positive when the velocity is increasing. Or when is the second derivative positive? When the first derivative is increasing. This is the first derivative. When is the first derivative increasing from 2 to 3? Speed is increasing when velocity values are going away from zero. Okay, whether it's positive, getting more positive, or negative and getting more negative, or looking at the graph, going away from a velocity of zero. Here's a velocity of zero. We're going away from a velocity of zero. We're coming towards a velocity of zero. We're going away. So I'd say 1 to 2 and 3 to 4. It's both this situation. Now, we realize we can go backwards. Switching things up. I'm giving you that we are moving on the y-axis. I'm giving you A. Cool. And this is where like it's nice to use P instead of X, because if I use X of T, but I'm on the y-axis, that doesn't make sense. So just understanding A is the second derivative. Cool. We will be able to go backwards to get the first derivative and to get which is the velocity, and to get the position function. But the position's on the y-axis, so that means like I'm going up or down on the y-axis. Initial velocity would be the position at time 0. Initial means time 0. So the initial velocity is 3. The initial position is 4. I'm going to find the exact velocity and exact position equations, do a sign analysis, find the appropriate positions to understand motion better. So it's like pretty much just do everything that we've done before, only now I'm going backwards. So like I will go backwards from P double prime to P prime by taking the antiderivative. I will use the 0.03, which gives me C is 3. If I plug in 0 plus C equals 3, C is 3. It works out that if you have like the time of 0, you get that the C is just the initial position. Like C is initial position. Not always, but most of the times. Cool. And we have P, which is 1/3 T cubed minus 2T squared plus 3T plus C. Make sure you can do that yourself. And if I have P of 0 is 4, I have 1/3 T cubed minus 2T squared plus 3T plus 4. Now, what analysis do I like to do? I like to do a P prime analysis to tell me about my position increasing or decreasing. Then I like to do a P double prime analysis to figure out when my first derivative is increasing or decreasing, which will help me determine when I'm speeding up or slowing down. We're not going to really go to concavity, but like the concavity of the graph of position helps us understand speeding up or slowing down. Yeah. So P prime set equal to 0. I get T minus 3, T minus 1. I'm not giving you a start or an end, so I guess we're just going for forever. Usually we start at 0 though. Do a sign analysis. P is increasing, decreasing, increasing. Make sure you guys do that sign analysis. Increasing our position on the y-axis. That means if my position is increasing, I am moving up. If my position is decreasing, I am moving down. This is not right or left anymore. Cool. P double prime set equal to 0, which is the first thing I gave. 2, if I plug in 3, 6 minus 4 positive, plug in 1 negative. Cool. Maybe start 0. That tells me how my velocity is changing, whether my velocity values are decreasing, whether like getting closer to 0 or further away from 0, positive, getting close to 0, or negative, getting further away from 0, if we're velocities are decreasing. I hope you're understanding. And now we can talk about speed, we can talk about everything, but the last thing they want us to do is to figure out some positions so that we can understand the last part of things, which is how far do we increase or decrease. P of 0 is 4. P of 1 is 1/3. Minus 2 plus 3 plus 4. That sucks. 7, 5, 16 thirds, or 5 1/3. P of 3 is 9 minus 18 plus 9 plus 4. Oh, okay, so that's 4. Cool. So I start at a position of 4. My position increases to 16 thirds. This is 12 thirds. So it increases 4 thirds. Then it'll come back down to 12 thirds, which means it'll decrease 4 thirds. And then it'll increase after that until I tell it to stop. Okay. Well, if we start at a position of 4 and I get to a position of 16 thirds, but then I come back to a position of 4, I'm located right of the origin. Actually, sorry, y-axis, y-axis. This is my position. Here's a position of 0. Here is my position of 4. My particle starts here, moves up, and then comes back down to where it started. So at 2, my position will be positive and decreasing. Now they ask you to find the position, velocity, and acceleration, so great. I'll have 8 thirds minus 8 plus 6 plus 4. So that's 8 plus 8 thirds. 8 is 24 thirds plus 8 thirds. That's not right. That's 2. Sorry, negative 8. 2 plus 8 thirds, 6 thirds, 14 thirds. Good. Good. That makes sense because I get to a max position of this like 16 thirds. And then at 2, my position is decreasing. It goes from 16 thirds to 14 thirds. Great. My velocity at 2 is 4 minus 8 plus 3, which is negative 4. Negative 4 plus 3 is negative 1. Does that check out? Yeah, my velocity is negative. I have a positive position that is decreasing. My position values are decreasing. I can move towards the origin, towards a position of 0. The origin is when my position equals 0. I have a positive position that is decreasing. This is my position is decreasing at this moment 1 meter per second. So at this moment, it's going from 14 thirds down, that many Ys per x, meters per second. Once the particle stopped, what are its positions? P of 1, P of 3. That's when the position is neither increasing nor decreasing. We should understand this. We should be getting the answers 16 thirds and 4. Was the particle moving up? I did not give you a time. From 0 to 1 and from 3 to forever. Should have asked you down. Since I didn't tell you how to stop, like how far does the particle go up? From 12 thirds to 16 thirds, it goes up 4 thirds. From 3 to whatever, it'll just keep going up forever and ever. If I should have said to stop at t equals 4, but then I wouldn't want to find that value, so whatever. Velocity is decreasing. My velocity is going to decrease when the derivative of position is decreasing, when my second derivative is negative. My velocity is decreasing from 0 to 2. Is the acceleration increasing or decreasing or constant always? My acceleration is 2t minus 4. This is tricky. Why did I give you this question? Tricky. Why is it tricky? I need to figure out whether my acceleration is increasing or decreasing. That's when my second derivative is increasing or decreasing. That's when my third derivative is positive or negative. My third derivative is 2. My third derivative is positive. My acceleration is increasing always. Speed, decreasing. When my velocities are positive but getting closer to zero by decreasing. When my velocities are negative but getting closer to zero by increasing. This is when my velocity and my acceleration have opposite signs. 0 to 1, positive, negative. That would be a time period when my speed's decreasing. Then 1 to 2, my velocity is negative. They have negative values that are getting more negative. So my speed's increasing from 1 to 2. From 2 to 3, my velocity is negative. My position's decreasing, but my velocity values are increasing. 2 to 3, my velocity is negative and increasing. Velocity negative, velocity increasing. So that's -4, -3, -2, -1 to 0. So that's going to be 2 to 3. Then 3 to infinity, my speed will be increasing. All right. Cool. All right, another y-axis. Who cares? Doesn't matter. Whether we're up and down with position increasing and decreasing, or right and left if we're on the x-axis with position increasing or decreasing. I'm giving you the velocity. I already gave you the derivative. I gave you the position at time 4 is 2, y of 4 is 2. You could change that to p of 4 is 2. I'm getting you prepared to see x and y functions because you'll see them on the AP exam, but I think you'll be better off thinking it as a position. Okay. We're talking about 0 to 3. That's nice. We have an interval. So let's do an analysis of our first derivative. We got 0 and 2. We're going to 3. If I plug in 3, I'd get a negative. If I plug in 1, I get a positive. My position is increasing, then decreasing. Great. My second derivative analysis is 6 minus 6t, which is 1. I'm giving you these because they're easy. My second derivative analysis, which is the acceleration, we have a problem if my cursor is already frozen. Going to 3. If I plug in 2, I'd get a negative, positive. That is telling me how my first derivative is changing. We understand that P is position, P prime is the change in position, whose fancy word is velocity, and how velocity is changing is acceleration. Cool. We do have a 0 at 0. Come on. What is the particle at rest? T equals 0 and t equals 2. What is its positions? Oh, hold on. I also need to go backwards, which means I got to find p. I got to take the antiderivative. I got t squared. I got a half and a 6, which is 3. I got a t cubed, which is nice because I got a 1/3 and a 3, which is 1. And I have a plus c. Oh, look at that. When my time is 4, my position is 2. 16 times 3 is 48. Did I like hurt my shoulder? Minus 64 plus c equals 2. So this is negative 16 plus c equals 2. C equals 18. My position function at a time is 3t squared minus t cubed plus 18. My position at time 0 is 18. My position at time 2 is 12 minus 8 plus 18. 4 plus 18, which is 22. Does this make sense? I start a position of 18. I increase by 4 to a position of 22. Great. When is the particle moving down? When its position is decreasing. The position is decreasing when the velocity is negative, or when the derivative position is negative. Position is decreasing from 2 to 3. How far does it move down? Well, I need to find p of 3, which actually goes back to 18 because of the whole way it works. So it goes up 4, it will then go down 4 to get back to where it started. Four meters or 4 units, whatever we're talking about. What is the displacement of the position of the particle of the entire interval? Well, my position started at 18. My position ended at 18. Overall, I have a displacement of 0. My change of my position is 0. I ended up exactly where I started. I moved, but I went up, then I went down. Velocity decreases when p prime decreases. That's when p double prime is negative, or that's when a is negative. P double prime is negative from 1 to 3. What is a particle slowing down? We'll just jump to the chase. When velocity and acceleration, or when p prime and p double prime have opposite signs, just to make sure you understand, that's when my velocity values are negative, which means my position's decreasing, which means I'm going down, but my velocity values are increasing, means my velocity is -4, -3, -2, -1, 0, getting closer to 0. We can have positive and decreasing velocity values, so your position is increasing, but at a slower rate. So it's tough to explain. I hope you understand. So V and A have opposite signs from 1 to 2, and that's it. How much does the particle's position change when it's slowing down? Oh, cool. I need to find the position at time 1. Now I know that my position is increasing, so I'm going up from 1 to 2. I know I go up a total of 4, but let's figure out how much. My position at 1 is 3 minus 1 plus 18. Which means my position, my y coordinate is what you're thinking of, is 20. My position at time 2, did I find that? Was 22. Great. Which means I went up, or my position increased. Two. Cool. Last question, but give you two particles. They're moving on the x-axis. So, x-axis, particle moving on the x-axis. If position's increasing, moving to the right. Position decreasing, moving to the left. We're cool with right and left instead of up and down. Position is a location. How position's changing, position increasing or decreasing. Looking at the derivative, that's the velocity. Looking at your velocity is changing. Looking at the second derivative, the change in the acceleration. Cool. We need a proper sign analysis of both equations because we have particle A. I imagine this is going to be like your quiz question because you have a test question just like this. Cool. Its position, and you're going to have to write down for your free response, like let P of T equals P sub A of T let equal X of A of T. Just be like, I don't like to use X of T. You guys don't understand it. It just means it's a position on the x-axis. I like to use P for position. It's just, I think it's going to be easier for you guys to understand. So position of particle A is T squared minus 6T plus 3. That means the first derivative of position is the velocity, which is 2T minus 6. If you want to write V of A is that. The second derivative of our position is 2. If you'd like to write A of A, like A sub A, great. We'll do our analysis. My interval's from 0 to 5. So 0 to 5 is a start and end. This is kind of new. I'll have my first derivative analysis focused on when my first derivative equals 0, which is at 3. I'll have negatives and positives, which shows me my position is decreasing then increasing. And then I'll have a second derivative analysis. Well, my second derivative analysis is easy because it's just positive 2 the entire time. So it's a positive value, which means my velocity values are always increasing. My position's change is always increasing. My derivative is already increasing. Probably want my positions at 0, 3, and 5. If I plug in 0, I get 3. If I plug in 3, I get 9 minus 18 plus 3. This is my positions. This is using the position function. T squared minus 6T plus 3. Negative 9 plus 3 is negative 6. And my position at time 5 is 25 minus 30 plus 3. It's negative 5 plus 3, which is negative 2. I'm going to make sure these values make sense. I start at a position of 3. I decrease 9 to get to a position of negative 6. I then increase 4 to get a position of negative 2. 3 to negative 6, 6 to negative 2. Subtract 9, add 4. Does this make sense? My position decreases, then increases. It does. Great. Particle B. Separate this out. I'm given the acceleration. So I'm given the second derivative, the change of the position. I got to go backwards. P prime will be negative 4t plus c. I'm told v of 0 is 4. That's p. That should be a b. Oh, sorry. That should be a b. That's p prime of 0 is 4. If I plug in 0, I get 4. Great. I'm going to go back again from p prime to p. The position of particle B, where it's located, got negative 2t squared plus 4t plus c. And I know my original position is at 2. So this is p of 0 is 2. So cool. So p of b, if I plug in 0, I'm going to get 2. That means c is going to equal 2. Great. I need a sign analysis of my velocity and my acceleration. I need a first derivative sign analysis. My first derivative sign analysis is focused on 1. We're going from 0 to 5. If I plugged in 3, I get negatives. If I plugged in 0 or a half, I'd get positives. We good. That is telling me how my position is changing, whether my position's increasing or decreasing. Increasing and decreasing means moving right or moving left if we're talking about moving on the x-axis, not moving up or moving down, which would be y-axis, and not like a graph, like what we did in Unit 3, sketching F. Second derivative is negative. P double prime is negative, which means P prime is decreasing, which is what we'll talk about with speeding up or slowing down. If my velocity values are decreasing, how that changes things. Might as well find some positions. Position at 0 is 2. Position at 1 is 4. Position at 5 is negative 50 plus 20 plus 2. So negative 30 plus 2, which is negative 28. Kind of makes sense. I start from 2, I go to 4, which means I increase 2. This is going to be a plus 2. I go from 4 all the way down to negative 28. I decrease 32. That's okay, because we can see from 1 to 5, we have a lot of time in which we can decrease. So all good. That's the one extra bit of analysis that we haven't done before. Do the particles end up further away or closer to each other compared to when they started? Well, this particle started at 3 versus this particle started at 2. So that means they were 1 away. So in terms of like their position. And then this particle at 5 ended up at negative 2 versus the other particle ended up at negative 28. So they ended up really far away from each other. Well, it's all relative, which means they are a total of 26 units away from each other. So further away. Particle moving towards or away from each other at t equals 1. It's a great question. It's just a great question. Well, you got to figure out where they're located. You could kind of do an analysis of like this guy goes from 3 to negative 6. This guy goes from 2 to 4. He stops at this position at 4. So it's really going to be all about this guy's position. If you're going from 3 to negative 6, that means you're already to the left of it and moving away from it. Let's just do a little bit more analysis just so we can definitively answer this question. I'm going to find my particle's position at 1. One minus 6 plus 3 is negative 2. Good. I go from a position of 3 to a position of negative 6. By the time I get to 1, oh, but my rate of change of position is increasing, which is why I'm kind of like slowing down from 0 to 3 seconds. So we will move left more quickly from 0 to 1 than we will from 1 to 3 kind of thing. This position is not changing, which means this particle is stopped at this point. This position at 1, how is it changing? It's -4. What does this value mean? P is decreasing by 4 meters per second. My position is negative and getting more negative. My position is -2, getting more negative. Therefore, it's moving away. I started at a position of 3, which is already to the left of a position of 4. My position is decreasing at 1. My position at 1 is actually -3. My position at 1 is 4, but my position is decreasing. This position is not changing at 1. I hope you understand that. It's not something to memorize, something to understand. When is the particles moving in the same direction? It's when their velocities have the same sign, or the derivatives have the same sign, or when their positions are decreasing or increasing at the same time. 1 to 3. My signs are the same of P prime, or P is increasing or decreasing. From 1 to 3, P prime is negative. It's got 150 pages. That's why it's a problem. What time intervals were both particles speeding up? Okay. Particle A is speeding up when its position is increasing at an increasing rate. When its velocity is positive and increasing. Velocity values are positive and getting more positive. So that's 3 to 5. So particle A is 3 to 5. V and A have the same sign. Or P prime, P double prime have the same sign. So that's, what did I say, 3 to 5? Okay. Particle B, 1 to 5. So since particle B speeds up from 1 to 5, that's when V and A have the same sign. We'll have together 3 to 5. Okay. Okay. Really important lesson. Next lesson, bring your computers. Forgot to tell you that. Bring your laptops next lesson. All right. Bring your laptops next class. I'll try to get the word out because you'll need it. All right. Hope you understand.